whatever lesson that will transpire this afternoon's discussion will be posted, no? So as notes for our lecture this afternoon. Okay, I haven't posted that this morning because it's not yet done, but this afternoon I will post it, no? So I think we can finish it early this afternoon before time 1:30. So we have to start, no? Because it's already 12:18. Okay, so I have to go to the one that we started this morning. So this is it, no? So as I recall, no, I will give an overview of what is the problem. Okay, so this is it, no? So it is being 11 meters long, overhanging 3 meters on portion BC. So and there are two types of load. You have a uniformly distributed load that's going down or 20 kilonewton per meter. This load occupies from A to C. So that means the total load is 220 times 11, 20 times 11. So a total of 220 kilonewton downward load. Now that is not the only load that is carried by the EDC, but there is also a downward concentrated load of 50, making the total load of 270 going down. Okay, so the support exerts the same. So you have 93.75 kilonewton on the other side and 76.55 on the other side. Okay. Now it's easy to construct the shear and moment diagram of this one, no? But using the what we call area moment method, the resulting moment diagram is a bit complicated, no? Because you have a second degree and then there's a lot of things to consider. So I make a strategy, no? I make a strategy. So first I'll do a tangent line at E and B. So this line is do a tangent line at E and do a tangent line at B. Now I'm interested in determining the tangential division of B, no, at this point to A, and I call this as TBA. So tangential deviation is governed by the secant theorem of area moment, no, that under those 2 point of 2 point being considered, you have to take the area of your NEI diagram multiplied by the distance of the centroid of that NEI diagram with respect to the point where you want to consider. Okay, at this point I consider it at A, so the point of reference is A. So this is the TBA. Now the problem really is to determine Y sub C. No? Y sub C is the distance from this point, no, on the right side. Okay, but I proceed directly to TBE, no. So you might wonder, ano, nagpalayo ta, no. Anyway, I have reasons later. Okay. So the problem is really determine the vertical deflection of point C. Here is constant. So my solution. So I don't want to complicate the moment equation, the moment diagram. So I have to make it as very simple as possible. Now, TBE requires only ED. You are not concerned about DC. So whatever the diagram here, you don't care what will be the form, what will be that one. So your only concern is ED. So I have to simplify this. I have to make this simple. So I make a moment diagram. We call that B. So I break them into three types of load. One is 93.75, and the other one is 50, and the uniformly distributed load. So okay, so make the moment diagram as simple as possible. TB is the area of the moment from A to B. Okay, moment over EI from E to B with respect from A. Okay. So in equation, that is area MEI E to B times XA, where XA is the distance from the center of gravity of your M over EI diagram with respect to point E. Okay. So I break this the moment diagram into three. Okay. So first, due to the 93.55 kilonewton load at A. Okay, so I'm only concerned with AB. So if you have a load which is only 93.25 going up, so I have also a positive moment, no? And since I have a triangle, then the area is no problem. Triangle is simply one half base times height, where base is 8 meters and the height is 750 kilonewton per meter. So I end up 3,000 kilonewton meter squared over EI. And now the x sub A, governed by this equation, this one, okay, x sub A is 5.33. So you look for the centroid of this triangle, and then distance from A is 5.333. So using the formula, this one, you have to multiply area of MA over EI times XA, which is 5.333. It becomes 16,000 kilonewton meter cube over EI. Now, only two loads are left because I have already done with 93.75, so I have to go with the uniformly distributed load. Okay, remember, only AB. Do not BC, whatever moment diagram is here. That is not our concern because I need only AB according to the formula. Okay, so the moment diagram is like this, like this. So the moment at B is 640. So this is a spandrel of a parabola. Now the area is simply 1/3 base times height. Okay. The base is 8 meters, the height is negative 640. So I got a negative 1706 as your EI. But we are talking about tangential division from B to A. So it's not simply an area, but it is an area of the ME over area diagram multiplied by the distance from the centroid of the moment diagram from A to B with respect to point A. Now, since this is a spandrel parabola, so this distance here is 2. Well, so what is left is 6 meters of the 8-meter long beam AB. So you will have negative 1706.6667 multiplied by 6, it will become negative 10 to 40 kilonewton per kilonewton meter cube over EI. Okay, the third load is you have 50 kilonewton load here, no? So it is applied in the middle of AB. So moment starts at that point going to be. Now the maximum moment of negative 200 kilonewton meter, and the distance from the center of gravity of that moment diagram with respect to A is 6.6667. So, ang A paingo sa middle is 4 na nadaan plus 2.6667 because sa middle paingo sa centroid. That makes distance of XA equal to 6.66667. Now, the area of your M over EI diagram is very simple. This is again a triangle with 4 as the base and height is negative 200. So, the area is negative 400. But we are not looking only about area because area talks only about slope. So we need a tangential deviation. So the by formula, it is the area of your M over EI diagram from point A to B times XA. But we have already determined XA and we have already determined the area of your MEI diagram. So the tangential deviation is negative 2,666.6667 kilonewton cubic meter per EI. So I have already considered all the three loads. No? As I have mentioned, there are only three loads, 1, 93, 50, and the 20 with respect to B. Okay, so basically, if I'm going to add all the moment diagram, paghahagya ko ng labas niya. No? Paghahagya ko ng labas niya. So, ang labas ng moment diagram na niya, maghahagya ko. No? But in this case, I break them into their component. Okay, component. So, since there are three moment diagrams, so the sum of all, so the total will become positive 11 dash 626 positive 11,626.6667 kilonewton cubic meter over EI. And that is the distance, no? If I am going to label ABC as this one, horizontal line, and the tangent line at point B as this one, TBE is just this distance, no? From the left. Now, so layo kay siya sa tinuod kay yara dinhi mong anon, yara dinhi ang imong ipangita. But you can have you have a relationship between Z and TBE, and if you are going to analyze it, naagid ay tinuod. Kung makuha din mong TBE, makuha sa din mo din it's just a matter of ratio and proportion. Now, since B to C is 3 meters and A to B is 6 meters, so the distance of this vertical distance, no, on the right portion, we call that Z, is just 3/8 of EBE, whatever value here. So the result of Z is equals to 4360 kilonewton cubic meter over EI. Okay, so let's go to our figure. Medyo doon na kita, ang Z nimo is kini siya, no? But YC is the below. Di sa ka makaingon nga ang YC equals to Z. No? So dili ka makaingon. Z is Z. Okay. So, ingana na siya, no? So, I will go back again to my figure here. I will bring this, no? I will okay, I will bring this one to the bottom so I can analyze again. This time I will zero na on the required. Okay. So oops. Okay, so this is it, no? Okay, na inanuktok atong abay na. See, Jasper who? Okay, who is Jasper? Jasper who? Okay, let's go. Again, I will put a load. So to yang ko ng load, move, copy, paste. So I put it there. Okay. Ay, tayo ang sabilan na yan. Okay. Okay. So that's it, no? Natin load. Yeah. So, ang lahat na pa rin. Okay. Copy, paste. Okay. So, muna ni siya ang load ko, no? Okay, muna yung load yan, no? So, ang depicted structure, di na akong piyahon ng magnitude sa load. Kaya madugay na tagsumot. Okay, muna siya ang depicted structure. Okay, please. Okay, ako na silibot lang dito. Ano siya ay depicted structure. Okay. Okay. Ay, nabot-sabot ka. Okay, mauna siya ang labas niya. Okay. So, ako rin yung kopyahon ang line, no? Okay, this, gusto, kopya din sa nandiyan. Yeah. Okay. So, actually, ang na-determine nato dani is kinipaw. Kinipa itong na-determine. Kiningi no? So, kung kopyahon ko ni siya, mo ni siya, ay, sobrang. So, na siya na line. Ano siya, kopyahon ko lang na siya na copy. So, kung siya isibog mo niya. Okay. So, nga ako yung pag-mabos. Sure. Okay. Ano na lang, no? Ano na lang. So, kini nga distance, actually, na-determine na nato na siya, no? Muna siya ang gitawag nato Z. Muna siya ang Z. Muna siya ang Z. Save sa question. Okay. So, kini nga distance up to that is muna siya ang gitawag nato that's very similar. Okay. So, from this is what we call the Z. No? Ito yung value is Z niya siya. And that is equal to 4360. 4360. Di na lang. Butang Z na lang na siya. Z. So, we are looking for this kanya sobos. Ni Moni at ipagita. P Y sub C. Y sub C. Buat na sa tagline theorem din no? What is the tagline theorem? Okay? If I draw a tangent line from this point, draw a tangent line, I will call this as tangent line C. This is tangent line C. Okay? And if this distance is your y sub C, and then this distance also is your z, okay, that's okay. Nakuha na nato ang z, ang yc wala pa. But I can also make a tangent line from this point and call this C. And this one is tangent line at B. Therefore, we are talking about BC now. BC. So, kung A ni siya, A na siya, kung i-atras kita. Ini siya mo yung kitawag B. B na B. Sabog ka. man siya ang B. Nga unahan, muna siya log C. So, ini siya muna siya. Therefore, doon na magkaduha ka tangent line, C ug B, ang tawag ani niya karon ini is tangent line CE. CE na siya. CB. So I will call that as tangent line. I will call that tangent line C BC. BC. No, meaning na ako sa C naging sure. Hindi na ako sa B sa direct niya siya sibog na dito. Sibog na dito. Mag-away sila. So ano sila? Subscribe. Okay, may look. Okay. This is Paday, Wimar Paday. Okay. So, Theta BC, no? So, actually, Theta BC, no? Theta BC, kung sa ba ng Theta BC, karon ako na siyang i-define. Okay. TBC na may nga T, B, C is the area of moment subscript na lang, subscript ng unit BC over EI multiplied by XC. Okay? So, muna siya, ang BC ani niya is that one. Subscript. Subscript na rin tanan. Okay, wala ko na ito siya. Din siya, yung mga ito siya. Subscript. Post patin yung subscript na siya. Copy sa niya subscript. So, in equation, TBC is equal to ato ning butang sa parenthesis in EB over EI. So, mana siya ang area sa EB over EI diagram. No, BC. This is BC. Sayop BC. Okay? So, subscript times X sub C. X sub C. Okay. So now you don't care about AB. What you care is only about BC, no? BC. So taking from this diagram, we can do the diagram of EB. So BC like this. Actually, the moment diagram of BC is like this. I will do. I just do the line ABC. Okay. Now this one is my. Okay. This one is my A, and let us see that this is my B, and this is my C. Okay. Now the moment diagram B actually is 3 meters only, no? 3 meters na siya. Ito na ba 8 meters para kumplito, 8 meters. So sibog din siya. Sibog may. BC actually is na niya ang moment diagram. Yan ang moment diagram, no? Doon na ni siya ay 1. Actually, doon mo nang ginagawa moment diagram, no? So, ang isa ako lang i-kuhan yan. Okay. niya yung moment diagram niya. Kaya ako na siya i-ghost. Ghost ko na siya. Ghost ko na siya. Para yun na ito nga dinetrentisado, anak. Gawas na siya. No? So, ito siya ibig na running line. Okay. So, next, I'm going to draw a vertical line. Determining the moment at B. Okay. So, that's the... Actually, makuha niyo mo moment sa B, mo isam na siya. 750, positive 750 minus 640. Okay. 750 minus 640. Nadayin ko yung negative dito isa. Minus 200. So, doon ako yung negative 90 din. Na ako yung negative 90. Negative 90 ni siya diha. Negative 90. Negative 90. Supposedly, no? Base lang ako sa moment din, ba? Kaya ang B din, 750 man, positive. Din negative 640. Din negative 200. So, I have a negative 90. Now, ang kini siya is 20 ni siya. 20 ni siya. 20. So, ang distance nga i-cover niya is 3 meters. That means 3 times 20 is you have 60. 60 here. But the distance from B is only 1.5. So you have 60 times 1.5. 60 times 1.5. So still 90. So the moment here, moment diagram here is like this. Okay. Actually, this is the real moment diagram of the figure. It looks like this. Okay. So we are only concerned of the solid line. Now, so the area of the M over kinesinia, okay, that one, alam sa x of c, okay, is equal to, this is a spandrel of a triangle, of a parabola. So where n equals to 2, so the factor there is not 1/2. 1/2 is only applied to triangle. This is a parabola, so this is 1/3. Spandrel of a parabola. Times base times height, the base is 3, multiplied by the height of negative 90. So we have minus 90 kilonewton meter cube over I. Mauna siya. No? Mauna siya. Okay, mauna siya. Ang value niya. No? Okay. So, how about x of c? X of c. Okay, it's all about x of c. X of c. Kanang x of c, kung parabola na siya, kini siya din kung mauni iyang tawag na centroid na din yeah. Ang distance na naiikan sa B is 3 divided by 4. So, 3 divided by 4 is 0.75. That means, ang distance ng centroid to C, may mo na siya 2.25 meters. So, that's 3 minus 0.25, that's 2.25 meters. So, if we are looking for this one, if we are looking for this one, okay. Yeah, that is. Then this one xc is equals to minus 90 times 2.25. 2.25, that is equal to the unit here is kilonewton meter cube over EI. Meter cube over EI. Okay, so 90 times 2.25, 90 times 2.25, you have minus 202.25. Okay. Now, supposedly, hindi tayo gamit ng absolute value lang because we are referring to a diagram. So, from this diagram, we can take the absolute value. So, just equate TBC equals to Z plus YC. No? So, using absolute value, no? Using absolute value only, because you will be using absolute values. Okay, I will release the one, absolute values. So we can see that TBC is equal to Z plus YC. And then YC is equal to P, finish siya. TBC minus Z. Okay, and this one is a subscript. And this one is a subscript also. Subscript also. So we have here YC. Sana to sa ubos. YC is equals to, I will use 202.25 over EI minus sila to 4060 over EI. You have here a negative 2.25 minus 4060 minus 2.25. So you have 4157.75 over EI. Unit is meter. Ano? Huwag mo natin nagamit ang moment ko sa kilonewton, Newton meter cube lang yapon. Huwag mo natin nagamit ang EI. Okay. Now, we will analyze why it's negative. No? Why it's negative. That means that ang Z mas dako og value kaysa YC, no YC. Okay. You mean that the TBC has a smaller value only, no? Meaning ang saktuan na niya is ani. Ang eksaktuan na niya nga deflection is like this. Okay. That TBC is just smaller than Z. TBC is smaller than Z. So, ang hitabuan na niya is ani. Copy. Shape. Okay, na siya. Okay. Then I will do tangent line again. So this one represents the okay. This one is the Z here, but Z is a very big value TBC. So ingon ani ang iyang kuan ani interpretation. Insert. Okay. This. Oh, shit. Okay, this is the supposedly mo na yung kuan. Okay. Mulaos kung tani siya dito, no? May anang tani siya, no? Insert anin tani siya yung shape niya. Ang taka-straight line pingon dito. Okay. But because of the load in the overhanging portion, this one also will bend. Will bend siya. So the bending of that actually, is TBC is lesser than the TDE. So nitabo na niya ang TBC. Ano siya? Nalad niya. So mao na siya yung depicted structure karon. So the this is the detection. Wala siya sa ubos, no? Wala siya sa ubos. Okay. Nasa sa taas. Okay. Why? TBC, this is the tangential deviation of this from this line is a smaller value compared to TEB. So, kinira ang imong gipangita actually. Kinira ang imong gipangita. Mao ni siya ang atong gipangita. Na diha. Okay. Home copy. Paste. Mao na siya yung pagkita. Okay. Niyo na lang natin pag-present. Kaya gamay na siya kayo. Ano na to. Yeah. Okay. So, muna siya atong ipangita actually. Y sub C. So, dili ingon ani. So, mga gihapon, no? Ato lang kini, kung ko patakibalo sa value niya, so, subaan na to, no? Actually, kini day ang distance from this to that is smaller than this value. So, muna nitabo ka niya, kini day nga distance ka na siya, gamay wala siya kaysa dani. So, this is the actual picture, no? Ako ni siya yung okay. So, mao nang nitabo sa imong actual nga deflection. So, that's all class, no? Well, I have to, okay. What would assignment, no? Assignment. Ako sa inyo ko na, group. Siya, nila yan. Group ang tawag na niya. Okay. So, what to assignment? Okay, siya nagkaban mo. Okay, so, okay. So, that's all. That's it, just no. So, mo to siya, no? Nasolve na nato ang deflection. So, we found out that already sa taas, above din siya sa horizontal. Okay. Ang akong analysis is that since gamay ang tangential deviation sa C paingon sa tangential deviation sa B with respect sa C compared to the distance G, so that means nga wala gid siya nakalapas dito sa ubos. Because the distance Z is from the horizontal line to the tangent line at B. Okay? But and the tangential deviation from C to tangent line B is only very small amount. So that means that the depicted structure is not lower than the horizontal line in the at point C. No, so it's still above the horizontal line. So for that analysis, that the distance Z and the TBC, it's Z that is larger, no, than TBC, not the other way around. If TBC is larger than Z, then your point C is lower than the horizontal line, like the first assumption that we have. Okay, that's why I correct the assumption, no, of the depicted structure. It's not lower than the horizontal line ABC, so it's above. So the final is the last. Okay, So, do you have any question, class?
Sir, ay question, sir.
Yeah.
Unsay pasabot nga negative ang YC, sir?
YC, negative. Actually, wala na siya kay pwede din na mo nabutangan og meaning, no? Pwede dili na mo butangan og meaning because you are working on the diagram. You are supposed to be interested only on the absolute value. On the absolute value. It only when you are adding two moment area wherein if they have opposite sign, you will obey what is the sign. Okay? But when it comes to magnitude, you just consider what is the magnitude because you are referring to your diagram. Okay? You're referring to your diagram. Now, in the last, I obtained a negative YC because it's in my computation, my TBC is smaller than Z. Okay, and TBC is actually the small triangle, no, not the triangle on the left side. When I show you the two triangles, TBC is the triangle at point C, no, at point C, and it still come out that it's bigger than the tangential division you do from point C. So that means that the diagram is still this one. No? It's corrected to this kind of diagram. Okay. So your question, what is the uh, one of the negative? Actually, mo lang na siya ang kuan ako. Mas dako ang value sa tawag ani Z kaysa TDC. Okay? Yan na lang na siya. So negative can be uh, pwede nimo siya ma-neglect, no? Pwede nimo ma-neglect because your analysis is already about the position of point C.
Ah, sige, sir. Salamat, sir.
Okay. Okay. So as your assignment, actually, butang kong assignment din niya, homework, no? Assignment yun, next meeting, assignment. Okay? So determine the deflection deflection deflection. Okay, I will show this, no? I will show this to you. Okay, I will show it. Okay, so that you will know what your assignment. Okay, so this is the assignment. Maybe I will put it in a box. So depiction at okay at point C. Okay, LCEI is constant. Okay, so the figure is this one. No, insert. You have one here. Okay, that will be your point A, and this is point B, and this is point C. Now, I will put a triangle. Okay, put triangle. It doesn't mean dili niya simply supported. This is still a simply supported. Okay, triangle at A. Copy that. Paste that. Okay, that. So, I will make this 10 meters. Okay, 10 meters. 10 meters. 10 meters. And this one is maybe 4 meters. Okay, I will put a load. I will put a load here. Himon ko na lang siya. 5 meters. 5 meters. This one is 4 meters. Now I'll put two loads only. Okay, one of the load is here. Okay, that is the first load. I will make that big, maybe like that, and maybe color of black. Okay. Now the magnitude of that is, let's see, 200 kilonewton, while here we'll have 100 kilonewton. Okay, that's the load. Then there is that. Boom, copy, paste. Kasi class, no? So, muna inyong assignment, no? Assignment. So, this is due. This will be March. Lapit na naman ng March. 15 karon. 16 ugma. 16 Martes. Merkulis. 16, 17, 18. 20, 21. Okay. The vertical deflection at point C. Vertical. Okay. Use area moment method. I'll say that. Okay. So that's all, no? Plus, no, for our lesson this afternoon. We just continue what we started this morning. Actually, sa face-to-face nga class, taas gini siya kayo nga solusyon sa Blackboard, no? But here, papareha yapon, pero di lang Blackboard ang sulatan. Sulat lang ko din sa Word, no? So, whatever is in the Word, I will upload it, no? So, because this is our one discussion this afternoon. Okay. And yes, portal, ano portal? Kasi abot tag lima. Lima ka assignment, wala niya submit. Katuloy akong gi-post last meeting na ato wala. Yung submit lang, idungan na lang tanan, butang ilang ngalan ninyo, no? So, kung doon na assignment nga wala na nga submit ninyo, hindi ko na submit ninyo. So, I will open one, a portal for you to submit. So, i-submit na lang ninyo daan ang file dito. Butang lang nimo assignment number 1, assignment number, something like that, no? Kay, mabutang na ko na dito sa column sa about that assignment sa checking na ko. Idungan na lang to ninyo kay ano man ang mga to, ha? Okay? Correct. Mao na siya. That's okay. Okay with me. That's okay. Mas maayo na yung nana. Mabutangan lang ni mo heading na this is assignment 1, assignment 2, nana. Ano pa? Manotice na kung ay taas-taas ni mong solution so dili lang ni siya isa ka assignment. And then identify na po assignment. So that also goes to other no others nga. I think you have the same concern, no? So, ingon ana, kung mga unsubmitted niyo assignment, as I have told you, before pa na, pwede ninyo isubmit yung mga late assignment, idungan ninyo sa mga submission ninyo, no? As one file. So, i-identify lang ninyo, no? Kay, ako man i-recall pa rin mga assignment, no? Tara assignment, so kung grade na ko, wala ka doon na column, I will, I will, sa tawag, i-contact ka kung ano, wala ka nag-submit. So, since wala ko man tanag ingon na, whatever mga delay, mga late nga assignment ninyo, it's not your fault. You are going to submit it as one document. Okay? Okay, so I will stop at this point. Okay, and just wait, no? Ako lang siya is one. So, okay. So, okay, so any other concern? Assignment is already okay. So, we dismiss early today. So, thank you. I'll see you Thursday.